Data science probability is often used to simulate scenarios. The code in the right simulates the birthday problem. Right now, the code stimulates a room with only two people to get random birthdays. The probability that these two people have the same birthday is really low. Change your number 2 to a higher number if you're choosing, but it says change this number and run the code. Is there a match in the simulation? What's the probability there will be a match? Keep checking, change your number to test out the different simulations. Note that if you make your number too high, big, the program will throw an error due to the way you have implemented some of the maths. This is a great example of needing to be mindful of possible inputs to your program. So we go for 660. I might see an error. There you go. Right, so the more you put in, so I had 766 the first time, so we'll get 77 now. So the probability that the two people in the room of 77 people have the same birthday is only 99.9898%. In your simulation, the following people have the same birthdays: person 10 and person 4. So what if you go for 23, say? The probability that two people in the room of 23 people have the same birthday is really nearly 50 points, so for half. In a simulation, no two people have the same birthday. So that's too low a number. I'll go for 50 this time. No, not 250. 50. So the probability of two people in the same room and people of 50 have the same birthday is nearly 97.0. In any simulation, the following people have the same birthday: persons 46 and 49. 9. Right, yeah, what's happened to you? Moving on. Right, programming. You've already seen how statistics and probability help us understand the data, but how do we actually interact with the data set? This is where the program comes in. With the right instructions, we can use the processing power of computers to analyze and visualize millions of data points. Once these instructions are written, we can then run them at any time, allowing us to replicate, update, and automatic early analysis as we receive new data. A set of instructions like this is called a program or an algorithm, and is written in a programming language which we usually refer to as code for short. In future Codecademy courses, we'll learn all the details of writing code to analyze data. For now, let's go over a common example of how computer programming can help us understand a data set and begin to make predictions. The data set we'll be looking at is a collection of flipper and ball measurements for 3 different species of penguins, collected by Kirsten Gorman at the Palmer Station in Antarctica. When you open this exercise, some code running behind the scenes loaded this data and created a visualization of the flipper and the ball measurement for 3 penguin species. Take a look at the visualization. You might notice that there is much overlap between species in the plot. For example, chin-crisp penguins seem to usually have longer bills than Adelie penguins, and so chin-strap penguins appear above Adelie penguins in the visualization. Regions like these predominantly feature one species of over another are called clusters in data science, and are often used when building computer modules to make predictions about data. For example, if we find a new penguin that has 180 millimeter long flippers and 35 millimeter long bill, we might conclude based on these clusters that a penguin is more likely to be an Adelie penguin than either of the two species. In our code running behind the scenes, we built a computer module to do this kind of prediction automatically. Change the flipper and bill measurement, determine and run the code. An algorithm we loaded for you will attempt to predict which species of penguin match the measurements you choose. How well you do think it does? What happens if you enter values that are between two regions or values outside of the region? In future code, you will learn to do all this yourself. In the meantime, you're welcome to explore the code we load for you by opening the code.py file and otherwise select next when you're ready to move on to the next lesson. Welcome to the behind the scenes code. Feel free to look through this code. Import matplotlib.py plot as BLT. Import Codecademy over Seaborn. Import pandas as PD. Import a package for generating a model of dataset. Right, yeah, but that video. Let's move on.